Recently we've seen how to draw a simple tic-tac-toe field, and with our new kind of skills and knowledge, let's try to apply this very practically, and let's try to expand our tic-tac-toe example a little bit. So what we're going to try to do in this tutorial is that we're going to try to create a tic-tac-toe game where we ask two users for input, and every time we print the tic-tac-toe field to the screen, and each turn a user can put in the field where they want to put where they want to put their kind of cross or their circle. So we're not gonna really go into checking for winning and all that stuff yet, because that's gonna take a while, and that would be a very, very intricate example. But we're gonna go and take it as far as printing the final fields after the user has put in an input, and after that, it's really just adding extra if cases and extra checks. But let's just go through it once. Let's see how far we get, and then yeah, we'll kind of sum up at the end. So the first thing that we want to do is, since we're going to be drawing this field a lot, we actually want to create a function that we can call to draw our field. So what we want to do is we want to define a function, and we'll just call this function draw field. And so we define a function using the def keyword to indicate that we're going to define a function. Our function name is going to be draw field, and then we're going to open and close the brackets to indicate that we're going to have some input here. And yeah, so right now let's just kind of leave the input empty. We're going to change this later, but in here we're just going to draw our field. Now we've already pretty much gone over this example in one of the earlier videos where we've drawn the field. It's just that now we're putting it inside of a function. So if you remember earlier, we used two for loops and some if statements to draw the field, but now we're just going to put this all inside a function. So we'll go through this a little bit quicker. We'll still explain everything as we go, but if you want to see this part of the draw field again, I would recommend you go back to that video where we just used for loops and if statements to draw the field, to kind of better understand what exactly is happening. But yeah, so let's just kind of go through it again. And so if you remember, let's just draw our tic-tac-toe field up here. So we start with a space, and then we have a vertical line and another space and a vertical line and another space, and then our next line is going to be our horizontal separators, so we'll have 5 of those there. And then our third line is going to be a space and a vertical line and a space and a vertical line and another space. And then our fourth line is going to be 5 horizontal separators again. And then our final line is just going to be a space and a vertical line and a space and a vertical line and a space again. So this is how our tic-tac-toe field is going to look like. These vertical lines here are vertical separators. These horizontal lines are our horizontal separators. And each of these spaces are fields where the users can put in their values. Yeah, and so we'll just make a range function, and we're going to start counting at 0 rather than at 1. So we'll go 0, and then let's just add some space here so that it's not confusing. So 0, 1, 2, 3, and 4. So these numbers are the numbers that correspond to these rows. So rows 0, 2, and 4 are the rows that have the space, vertical line, space, vertical line, space. And rows 1 and 3 are the ones that have the 5 horizontal dashes, or what we're going to use it for is being the horizontal separators. So these are just going to be the lines of our field, just like we've had before. So let's start off with our for loop. And what we're going to do is we're just going to go for, and we want to create the rows. So we're going to go use the temporary variable row. And we're going to go in the range up to but not including 5, so that we get 5 numbers. These numbers are going to be 0, 1, 2, 3, and 4, because we go in a range starting at 0, which we got by not putting a starting value, going up to but not including 5. So we're going to get the values 0, 1, 2, 3, and 4 for our temporary variable row. And so if we remember from before, we want to check if row, as we see here, if row is even, if it's an even row, we want to print this. So we want to print the space, vertical line, space, vertical line, space. And if it's an odd row, we want to print this horizontal separator. So to check if it's an even row, we want to check if we divide row by 2, do we get a remainder? So if we divide row by 2 and the remainder, and if we compare this remainder to 0, so if we divide row by 2 and the remainder is 0, that means row is even. Or that means 2 fits in perfectly into row. So for example, 0 divided by 2, we get no remainder. 2 divided by 2, we get no remainder. Since 2 fits in once perfectly into 2, 4 divided by 2, we get no remainder. Since 2 fits in twice perfectly into 4, 1 divided by 2, we get a remainder of 1. Since we have this one remainder. And 3 divided by 2, 2 fits in once perfectly into 3, and then we get 1 divided by 2, which gives us a remainder of 1. So if our remainder is 0, or if we have an even number, then what we're going to do is we're going to print this line here. And so let's just add a comment here. Print writing line. So we'll just call it this. So this, and we'll add the code here in a second. And else, so if row is not even, or if it's not perfectly divisible by 2, we're just going to print out 5 horizontal dashes, like this. So if row is 1 or 3, we're just going to print out these horizontal dashes. So let's go back to this if statement here. And so what we're going to do here is we're going to loop through, and we're just going to print this. If we remember from last time, we printed the space and the horizontal, the vertical line individually rather than printing it all at once. So we used another for loop, and we looped through column by column. So for column in range, and let's also just stick with 5, so going 0, 1, 2, 3, 4. So if we number that, we get 0, 1, 2, 3, and 4. So these are the columns that we have. So this is column 0, this is column 1, column 2, column 3, and column 4. So we see column 0, 2, and 4 actually correspond to the spaces, the writable spaces, and columns 1 and 3 correspond to the vertical lines, so the vertical separators. So here we're going to take on the values again, 0, 1, 2, 3, and 4. So this is column's going to take on the values 0, 1, 2, 3, and 4. And once again here we're going to check if our column is even. So if we divide column by 2 and we look at the remainder, so if we divide column by 2, and if the remainder of dividing column by 2 is 0, so if column is even, so 0, 2, 4 gives us a remainder of 0 if we divide by 2, what we're going to do is we're going to print a space. Now remember I said we're going through this a little bit quicker because we already covered this in an earlier video and we don't want to kind of repeat all of this. So if this is a little bit too fast or you want to go over it again, I would recommend going back to that video, checking it out, really going through what we're doing. But this is just kind of a short recap session for printing this field. And if our column is not divisible by 2, we want to print out, or else we want to print out, the vertical line. And now we also remember that we need to put in the space, we need to have spaces here, or we need to have no separation so that we stay on the same line. So we need to change our end, and instead of putting a new line, we just want to stay on the same line and not add any extra special separation. We also need to change the end here to be no extra separation, just kind of continue where we left off. And we also need the special case to check, or rather we need to say if our column is not the final value, then we have no separation, but if it is the final value, then we need to print a new line. So if column is not equal to, and our final value is going to be 4 here, rather than 5, which we had in our last example. So if column is 4, what we need to do is we need to print a new line afterwards. But if it's 0 or 2, we want to stay on the same line so that we can have these vertical lines here. So if column is not equal to 4, so if column is 0 or 2, we want to continue writing on the same line. But else, if column is 4, we actually want to add a new line at the end so that we print this horizontal separator on a new line. So else, we would just want to print a space, and we're not going to change this extra end. We're just going to leave it as a new line. And so let's just take out this comment since we've completed this part now. And let's call this function once to make sure it works. So we'll call draw field. And if we call this function, we should just be able to draw this field here. Let's run this. Let's see what we get. Yeah, so we get what we expected, and what we also got last time. We got our Tik Tak Toe field. So we loop through row by row, and each row we either print the writable parts or the horizontal separators. And if we print the writable parts, we actually go through it column by column. And here we print the space, and then we stay on the same line, and we print the new line, and then we print another space, and then we stay on the same line, and we print this horizontal bar again, just like we had here, and then we print a space, and now we actually print a new line too, so that the next time we print something, we end up on a new line, so that our horizontal separator is not on the same line anymore, but it's on a new line. So if we call our draw field function, this is actually what it does. It draws the current field for us. So yeah, cool. So now we have a function that we can call whenever we like, and every time we call it, we draw the current standing of the field. Okay, so now let's make it interesting and let's expand on this a little bit. So we'll use a similar tactic that we used before to make an infinite loop. So we'll do while true. So if you remember, using the while loop, so if we put in while true here, that's shorthand for writing while true is equal to true. So what we created here is a while loop, and in this while loop we put in the condition true, and this condition is shorthand for, or what actually happens here, it checks if true is equal to true. Oops. So it's only with one E, and since it's always going to be equal to true, we're just going to have an infinite loop. Now technically we don't need an infinite loop. We actually only need to go through it 9 times, so we could also make a for loop, for example, and just go through it 9 times because there can only be 9 input values. But let's just stick with an infinite loop right now, just so that we kind of get familiar with it and we know how to implement an infinite loop if we ever need one. So yeah, this while true here is just shorthand for writing while true is equal to true. So this is the same thing as this. So while true is the same thing as while checking if true is equal to true. But let's just leave this out because we don't really want to write that much. We want to write something that works in as little kind of characters as possible. We don't want to waste our time writing just a bunch of characters. We want to keep it short and to the point, but we want it to work nicely. So that's why we'll just use this shorthand here. So what we're going to do is we're going to ask for input. So we'll create a variable called move. Let's call it move. And what we're going to do is we're going to ask the user for input. And then we want to ask them, so what do we want to do? Well, we need to get the column and we need to get the row. So what we're going to do is we're going to ask the user for column and row input. So we're going to need to ask them for a column and a row. So let's ask them for a row first. Please enter the row. So first we ask the user to enter the row that they want to put. These are the rows that they want to put, that they want to move in. So we'll call this variable here move row. And so we'll use the conversion to an integer. So we'll type in the int, and we'll put this around the input. So what we're doing here is we've created a variable called moveRow, and inside of this we're going to store the row that the user wants to put their move into, and we're asking the user to enter a row, or enter the row, and when they enter it, we're going to try to convert it to an integer. So they're going to enter a number, hopefully, and we can of course check for this later, and we can make special cases, but let's just trust the user, and let's have them enter a number, and this number is going to be put in as a string through the input, or as a word, so it's going to be inside of these quotation marks, and to convert it to a number or an integer, we're going to use the int keyword and then the open and close brackets, and we're going to convert the string or the word here that we get to an integer or a number, and we're going to save this in the move row. So that's the row that we want to place into. And now we want to ask for the column, so we'll have another variable called move column, and we'll just do the same thing as above. We ask for input, and we'll specify to the user, please enter the column, just like this. So we created a variable move column. We ask for input, please enter the column, but since our input is going to be in the form of a string, or that's the way it's going to be saved, so all the input we get is going to be kind of inside of these quotation marks, so it's going to be a word or a string. We have to try to convert it to a number or an integer again, so we have to use int around the input, and this is going to try to convert our word or a string that we get in here to a number or an integer, and it's going to save this in move column. So what we do is we ask the user first to input the row, then to input the column, and if possible, and we trust the user here that they enter an integer, we convert their input to integers, and we store it in the move row and in the move column variables. So cool. Now we've got the moves. So what do we do with this? How are we going to apply this? So the best thing that we can do to apply this is we have to kind of save this as a list. So there are two things actually that we need to do. One of them is we need to apply the move, and we need to save the move. So that's one thing. We need to apply and save the move. The second thing that we need to do is we need to check which player's turn it is. So do we put it in X or an O? So let's start off. Let's start off with the player. So we'll just start off with player is equal to 1. So we're creating a variable called player, and we're going to have it equal to the value 1. So this kind of means our player is going to have the value 1. So effectively, what we're reading is our player is currently player 1. And what we're going to do is we're going to check, let's make on a new line, we're going to have an if statement. And the first thing that we want to do is we want to see which player's turn it is. So if player is equal to 1, so if player is 1, then we'll write this in a second, make move for player 1. So what we're doing is if our player variable here has the value 1, we want to make the move for player 1, else our move is going to be made for player 2. So make move for player 2. So what we're doing is we've created the player variable, and we've asked for the move of the player, that's the row and the column, and we've checked for, and then we're checking which player's turn it is, and we make the appropriate move. So how do we make a move? Well, the way we're going to make a move is we're going to save our playing field in a list. So what we want to do is we want to keep track of all of this in a list. So we'll make a list, or we'll create a variable, and inside of this variable we're going to save our playing status, so or our playing field, or our current field. So current field is what we'll call our variable, and our current field is going to be equal to a list. And inside of this list, we're just going to save, we're just going to have all of these values here. So inside of this list, we're going to have our first element, so element 1, then we're going to have element 2 and element 3. So we're going to have 3 elements, and we'll just have it so that each element corresponds to a column. So we want to have our current field, and we're going to have it be in rows, and each row, or in each kind of element, is going to correspond to a certain column. So element 1 is going to be column 1, element 2 is going to be column 2, element 3 is going to be column 3. So how would we do this? Well, element 1, for it to be column 1, it actually needs to save 3 values. So how are we going to save 3 values in one element? And so the way that we can do that is we can actually put another list inside of a list. So we've seen this earlier, and it may have been a bit confusing then why we would ever want to do that. But we're going to do it now, and we're going to see it's actually really, really practical in this case, because it really lets us keep track of our playing field in a kind of, it lets us kind of have a better picture of it. So the reason that we're doing all this formatting is because it helps us imagine it better. And so it'd probably be easier for us to imagine having a list of 3 elements, and each element corresponds to a row. We can kind of picture that nicely in our head. So we'll see that in a second. So let's create another list inside of our first element, and this first list is going to correspond to these 3 elements. So column 1, row 1, column 1, row 2, and column 1, row 3. So we're just going to have our standard values in here, and let's just have the standard values be space, so kind of empty. So our 3 elements are going to be 3 spaces, like this. So just like we've had up here, our current playing field, or our current row, or the current column that we've created is the first one, and our column value 1 for row 1 is just empty, like it is right here. Our column value for row 2 in the first column is also empty, and our column value for row 3 in our first column is also empty. So we're just trying to replicate this empty field in here. Now we'll do the same thing for element 2, because all of these values are empty too. So we'll put in another list here, and we'll create 3 elements. Each of these elements corresponds to a row, and they're all empty. So we'll put an empty element here, and then the comma to indicate the next element, and then an empty element, and then another empty element. So each of these elements here correspond to rows 1, 2, and 3, so 1, 2, and 3, in column 2, since they're the second element. And we'll do the same thing for element 3. So we'll create another list here, and we have to make sure that we actually close this list, not that we need 2 kind of ending square braces, not just 1. And here we'll have elements 1, 2, and 3 also just be spaces, just like we've had back here. So this may look extremely weird at first, but give it some time, try to look at it, try to understand what we're doing. So I'll explain it one more time, but it's really useful if you can kind of picture this in your head. So that the whole point of the way that we're formatting this is that it's easier for us to kind of imagine. So right now we've created kind of one line, but if we can imagine that we take this line here and we make it 2-dimensional, so that if we drag this kind of down like that, and this down like that, and this down like that, that we kind of get this playing field here, so that this value here, for example, corresponds to this value. The second value in the first element corresponds to this one. The third value in the first element corresponds to here. Then we move on to the second column, which is the second element in this big list. And so the first value corresponds to the first value here, the second value to the second one, the third one to the third one, And then our final element, our third element, the first value corresponds to the first one, the second one to the second one, and the third one to the third one. So what we've created is we've created a list, and in each of these elements we save the column. So this is column 1, column 2, column 3, and in each of these columns we've saved the elements row by row. So row 1, row 2, row 3 for column 1. Then column 2 here we again have row 1, row 2, and row 3. And for column 3 we have row 1, row 2, and row 3. So this is kind of a way that we're going to simulate our playing field, or the current status of our playing field. And we started off empty because our playing field is going to be empty, because no one's made a move yet. So let's make a move. Let's go back in here and let's have player 1 make a move, or let's put in the move for player 1. So what we want to do is we want to access our list, or we want to access our list here. We want to access our current field, and we're going to update it. We're going to access our current field, and we want to access the row and the column. So how are we going to access this? How are we going to make sure that we're accessing the right element? Well, if we remember, in this big list, in the current field, this big list, each of these big elements here, each of these lists corresponds to one element, and these elements are the columns. So these three elements here are these three big lists, these three smaller lists here are each elements, and each of these are a column. So the first thing that we're going to access in this current field is the move column. So each of these small lists corresponds to one column. Column 1, column 2, and column 3. Column 1, column 2, and column 3. So that's why the first thing we need to access is the first column. And that's just because that's the way we're imagining it in our head. And if you want to imagine it differently, and if you want to go row by row, you can also do that. So you can say this is row 1, and then you can imagine this one being down here and saying this would be row 2. So if we kind of imagine moving this down here, we would have row 2. And if we imagine moving this down here, we would have row 3 below here. And then you can go with move row first. We're going to imagine it in our head that each of these we kind of turn by 90 degrees like this so that we get our 3 columns. And so that's the approach that we're going to take. And that's going to be your mental image of this list. But you can do it another way. But we'll just say that each of these is a column. And then, so we access the move column, and then we get one of these 3 elements, and each of these elements is a smaller list that has the row value. And so inside the column, we want to access the move row, so the corresponding row to this column. So first we access the column, because that's the way we're imagining it, and then we access the row, which is inside of each of these columns. So again, column 1, column 2, column 3, row 1, row 1, row 1, row 2, 2, 2, and row 3, 3, 3. Now, technically in terms of indices, it would be column 0, column 1, column 2, and row 0, row 0, row 0, row 1, row 1, row 1, row 2, row 2, row 2. So that's how it's like in terms of indices, but for practical terms, it's also just columns 1 through 3 and rows 1 through 3. So you just have to kind of also make that conversion in our head, that we have the first row is actually index 0, for example, just because we start counting at 0 in programming. But yeah, so we're going to update the column and the row in our current field, and we're going to assign a new value, and let's give player 1 the cross. So our current field is going to be a cross for player 1, and if we do the same thing down here for player 2, so we just access the same thing, we just do the exact same thing here. We want to access the column and the row. So in our current field, we access first the column because that's the way we're imagining it in our head. If you want to do it row by row, that's fine. You just have to switch these two, and you kind of have to keep track of that. Yeah, you have to keep track of that up in here, but we're just do it column by column. So we'll access the column. We'll imagine that each of these is one column, and then we want to access the row. And in here, we'll just put in a circle, or the O. So if it's player's 1 turn, we'll put in current field 1, or we'll put in an X. And if it's player 2 turn, we'll put in an O. And since we want to alternate players, if it's player's 1 turn and they make their move, now player is equal to 2. So in player 1, what do? Well, we have a move, and then we check if it's player's 1 turn, and if it is, they make the move. And now we change the player to be equal to 2. So now it's player 2 turn. And if it's player's 2 turn, they make the move, and now we change the player back to 1. So if it's player 1 turn, make a move, put in the cross, player 2, now it's player's 2's turn. And if it's player's 2 turn, we make the move, put in the O or the circle. Now it's player's 1 turn. And since we're using the else statement here, if we execute this if, we're not going to go into this else, so we don't have to worry about having a player 2 here and then overwriting what we've had before. So if it's player 1, we'll execute all of this, and since we only have an else statement here, we'll skip it if we executed the if, and then we'll just kind of start the loop again from the beginning, and then player 2 can put in their values. So now we've done that, and we can run this, but we haven't really linked it to our board yet. So that's what we'll do next. The next thing that we're going to do is we're going to link it to our board. But let's just run it once, see what we get now, and then yeah, let's move on from there. So we see here, please enter a row. We're going to have row 0. Please enter a column 1, and well, nothing happens now because we're not really doing anything else, but we're asking just for the row and the column, and then technically we've made a move, but we're not really seeing it yet. So maybe let's add some print functions to kind of see what we're getting. So let's stop our code, and at the very end, let's print the current field, and maybe in the beginning, let's print which player's turn it is. So player's turn, and here let's just put in the number of the player. So we'll use the comma, and then we're going to put in the player. So if you remember this from the input and output, so this is a special format. We have our string, our player's turn, and then we put a comma separator here, and then we put in the variable player, which either has the values 1 or 2. And so we'll get player's turn, and let's put a space here so that we have some separation, and we'll get either 1 or 2. And so this is just, this comma allows us to actually put in an integer here, and the print function will just convert it all internally and make a big kind of string or a big word out of it. So yeah, and maybe in the beginning, let's just also print the current field before we even enter the loop, just so that we can see everything that's going on. And maybe let's also add a new line after each of these input requests, also just for formatting. So we're just making it a little bit neat right now. Let's run the code. We'll get some, and then we'll see what we get. So first we get the list, the empty list here. That is, if we make this really big. So first we get this empty list here, or the list that contains a bunch of spaces, which is our current field that we have here. So our current field is just these 3 elements containing the 3 small lists in this one big list. That's what we get from here. Then we enter the while loop. We print the player's turn. Currently player's turn is 1. Now we ask, please enter the row. Now we enter the row. Let's put in row 0. Now we ask for the column. Let's put in column 0, 2. And now we see we've updated the list. So player 1 has made the move column 0, so first element in this list, and row 0, so first element in this small list here. And now it's player's 2 turn. Let's say player wants to access row 2 in column 1. So column 1 is actually the index is actually the corresponding index. So 1 here actually corresponds to column 2, and 2 here in the row actually corresponds to row 3, if we think of it how we counted the rows before. But since we're dealing with indices rather than actual numbers, so we'll see here for column 1, so that would be the second element in the list. So this is column 0, which is the first element. This is column 1. And inside of column 1, we access row 2. So we've got row 0, row 1, and row 2. So we've seen that we've updated our list again, and we've put in player 2's turn, and we've put in the O here. And we see up here that it's player's 2 turn, and then we make the move, and now it's player 1's turn again. So yeah, let's stop our code. And so we've kind of put in this basic functionality of making the moves, but now the next thing that we're going to need to do is we're going to need to expand on this, and we're going to need to expand on it in such a way so that we can now kind of incorporate it here into the draw field. And we want to transfer our current field and the input to the draw field. So every time a player makes a move, we want to draw the field, and we want to see the updated version. So that's what we need to work on next. We've just gone through starting our Tik Tak Toe example, and let's continue where we left off. So where we left off is we've made our moves. So we've asked player 1 and player 2 to make their moves, and we were able to make the moves, and we were able to print them out in the current field. So if we run our program again, we'll just see it. We print out our current field that's empty, and then we print out that it's player 1's turn. Then we enter a row, so let's say row 1 in column 1, and then we make the move and we print our new field, or a kind of representation of our new field, and now it's player's 2 turn, and we enter the row, so let's say row 2, column 2, and now we make the move for player 2, and we put their move in here, which corresponds to column 2, so the third element of the big list, so 0, 1, 2, so that's column 2, and row 2 is 0, 1, 2, so that's row 2. So we've made the move for player 2, and now it's player 1's turn again. So for example, here we can put in row 1, column 0, so that gives us our first element. So column 0 is our first element in the big list, row 1, row 0, row 1, so that gives us this middle element here. So we make the move for player 1 again, and now it's player 2's turn. So we've been able to create, or we've been able to save these player moves inside of this list, or this nested list, so 3 lists inside of a big list that is supposed to kind of resemble our playing field. And we've also made a draw field function which can draw the field for us. Now what we need to do is we need to get our playing field into our draw field, and we want to be able to just kind of be able to draw this out inside of this Tik Tak Toe field. So let's stop our code, or let's stop this instance, and let's go about that. So let's try to put our current field into this draw field, and each time we'll just draw the field that we have. So how are we going to go about that? Well, what we need to do is we need to add an input to our draw field, and so into our draw field we're actually going to add the current field. So yeah, we're just going to put this into here, And so this is going to have kind of all the data, all the moves, and we'll put that into the draw field, and we'll use this information inside of this draw field function to draw the field. So our input is going to be our field, and so this is just going to be the local variable name that you're going to use. We could technically also call it current field, but let's just call it field to indicate that technically this thing here and this thing could be different. They're not different, but the names could be different. So we'll refer to it field as field in here, even though we're actually talking about the current field, but we'll only use that when we actually input it in the code. So we'll see that in a second. But in here, let's just assume we have a list like this, and we assume that the list has 3 elements, and each of these elements is itself a list and has 3 elements. So that's kind of the format that we assume for field. And so how are we going to use this? Well, what are some things that we need to change? Well, we need to change, in here we need to change these values. So we need to change the actual values, and we would rather use the values from here rather than just putting them in manually. We actually want to use the values in the field. So we can keep our vertical lines, our vertical separators, and our horizontal lines, so our horizontal separators, but we do want to use the values here from our current field. So how are we going to go about that? Well, let's go through this again. Let's see what we're doing, and then let's see how we can get out the values from our field. So what we do first when we draw the field is we go through row by row, and we start in the range from 0 to up to not including 5, so 0, 1, 2, 3, 4. So our row goes 0, 1, 2, 3, 4, and if it's an even number, we go into this statement here, and we enter another for loop, and we go through column by column. Now for even columns, we go into this if statement, and the even columns are the ones that interest us, because those are actually the ones that give us the values of the players. So the moves of the players. Either it's an empty field, so nothing has been done, or a player has made a move. So that's what these even values give us. The odd values just give us these vertical lines. So the odd values in the columns give us these vertical lines, and the odd values in the rows give us these horizontal dashes, or these horizontal separators. So yeah, let's go in here, and what we want to do is we want to change this print statement to something a little bit more general. So what do we want to do? We want to print the corresponding element in the current field. So we're going to go into our current field, and well, locally here it's going to be called the field. So we're going to go into our field, and what we're going to do is, since our field is going to be structured column, 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 the first thing that we want to do is we want to access the column. And the second thing that we want to do is we want to access the row. So what we get here is we get our columns, column, 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 column here, and then each of these columns has row, row, and row. Now, we're running into a little bit of a problem, and that's because we're going through the range from 0 to 5, so we're taking on the values 0, 1, 2, 3, 4 for our columns, and 0, 1, 2, 3, 4 for our rows, but our field actually only has 3 elements, so 0, 1, 2, and each of these elements has a list itself which only has 3 elements, so 0, 1, 2, and those correspond to our columns and our rows. So we're going to need to adapt our rows a little bit. And so what we want to do is we want to be able to change this column here, or this column here, and this row here. we want to change it from 0 to 4 and 0 to 4 to either 0, 1, or 2. So what is a smart way that we can do that? Now, of course, there are different ways, so I could completely change my draw field function, and I can only loop from 0 to 5, and I can say, I print my value, and then I print the separator afterwards immediately, without using a else statement and stuff, and I have special cases, but we don't really want to rewrite our whole draw field function. We're a little bit stubborn, and we're going to say we wrote this once, we're going to figure out a way around it. So how are we going to map our columns 0, 2, and 4 to the numbers 0, 1, and 2? So what do we want? Well, let's just kind of write out what we want so that we can visualize it. We want to change 0 goes to 0. We don't really care what happens to 1 since we're not going to use it. 2 goes to 1, and we don't really care what happens to 3. And 4 goes to 2. So 0 goes to 0, 2 goes to 1, and 4 goes to 2. So what are we doing? Well, effectively, we're dividing our columns by 2. So that would be one way to get these values. So if we divide our column by 2, well, 0 stays at 0, 2 actually goes to 1, and 4 goes to 2. So cool. What we've just did is we found a nice mapping. So we've run into the problem that we're going through the values 0, 1, 2, 3, 4, because we're going kind of column by column, and we're also printing the vertical separators. And here for the rows, we're printing the horizontal separators. And we need to figure out a way to map that to columns so that we can use index 0, 1, and 2. And so we found a way to do that. So if we divide our columns by 2, and this only works for some, of course, but it works for the ones that we're interested in. So we're lucky. So now we figured that out. We've said, aha, well, technically, if we divide our columns by 2, that would give us the right value for the column, but how are we going to implement this? So inside of this if statement, let's just create a new column or a new variable, and we'll call it the practical column. So the practical column is the column that we can actually use in our field to access the variable. So rather than having the column value, which takes on 0, 1, 2, 3, 4, we're going to have our practical column, which is going to take on values 0, 1, or 2. And since we only change the practical column when our column is even, or if we divide it by 2, we get a remainder of 0. So what we can do is our practical column is going to be equal to the column value divided by 2. So what are we doing? Well, our column takes on the values 0, 1, 2, 3, 4. Now if we divide column by 2 and we get no remainder, then we assign a value to a practical column, which is the value of column divided by 2. And so the only values that pass here for columns are 0, 2, and 4. And this gives us the values 0, 1, and 2 for our practical column. So we can actually use our practical column in here rather than our column variable, and this is going to give us the columns that we want here in the field. And now we can go up here and, well, we want the same thing for our rows. So just like for the columns, we want 0 to go to 0, 1 we don't care, 2 goes to 1, 3 we don't care, and 4 goes to 2. So we can do the same thing in the rows, and we can create a new variable called practical row, and it's just going to be equal to our row divided by 2. And since we're only going in here when row is even, so if we divide row by 2 and we get no remainder, so the only values that go into this if statement for row is going to be 0, 2, and 4. And for these values of row, our practical row is going to have the values 0, 1, and 2. So, I mean, what we've did is kind of complicated in some sense. So we ran into the problem that our row and column take on the values 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4. But we found out a smart way to get around that. So to get values 0, 1, and 2 when we need them, we were able to kind of create, we were able to create a mapping, or we've created a new variable that is equal to the column divided by 2, because that works out nicely to give us the actual column that we want. So rather than having to rewrite our whole draw field or to add extra if statements or extra checks, we just sat back a little bit and we thought, well, what do we want? We wrote out what we wanted. So what we need is we need 0 to go to 0. We don't care about 1. We need 2 to go to 1. We don't care about 3. We need 4 to go to 2. And so we were able to create a nice kind of relation, drawing this out and trying to and really understanding what we need. And of course, we're lucky that we chose 0 to 5 rather than 1 to 6, because if we chose 1 to 6, then we would have to do some extra math. For example, we would have to subtract 1 away and then divide by 2 or so. I mean, it would all still be doable, but we would just have to figure out another way to get around it. Or, of course, we could rewrite our whole function, but we already wrote it, so we want to keep it. And now we figured out a nice way to actually get the practical column here and our practical row here. So, yeah. So this is kind of a nice example of using what you already have and trying to figure out what you want to get. And the nice thing is that we can just create new variables, and all we had to do is just divide the value by 2 when we needed it, and that gives us the right value for the column and for the row. And so creating these new variables is also just a really nice kind of technique that you can use. You can always create new variables, use them when you like, use them to make your life simpler. And so we were able to create 2 new variables, and we saved ourselves a lot of time rather than having to rewrite our whole draw field function, or rather than having to create a bunch of special if statements or other types of checks, or if or else statements. And also here inside of the space, we'll just put in we also want the field and the practical column and the practical row. So we went from the hard-coded version of just printing an empty field to the more general version of printing the field that we have here. And so we put that in there. So yeah, so this is kind of all a little bit weird, and it's a little bit complicated. So let's just run our code once, and then let's go through it a little bit, and let's really understand what we did. Yeah. And so let's make use of this draw field function. Let's draw the field first. So we'll call draw field, and our field here is actually going to be the current field. And then instead of printing the current field, let's take this out and let's call the draw field function. And in here, our field is also going to be the current field. So all that we've done here is, instead of printing this list, we're actually using the draw field function that we created earlier that draws our field, and we'll draw it once in the beginning when it's empty, and then we draw it every time after a player makes a move. So if we make this bigger again and we run our code, let's see what we get. Well, we get an error. So the list indices must be integers or slices, not float. So what we forgot up here is that since we're dividing by 2, we actually get values of 0.0, values of 1.0, and values of 2.0. So what this error is telling us is that we need to have integer values, not floats. So integers are whole numbers, floats are decimal numbers. So we need to convert this to an integer. So we are going to put our integer around here. And what this does is it just kind of cuts off the decimal numbers, and it converts 0.0 to 0, and 1.0 to 1, and 2.0 to 2. So for us humans, it's not really that big of a difference unless you're really technical and stuff. then yes, 0.0 is technically different than 0 because there's more accuracy, but generally we say 0.0 is the same as 0. But for the computer, there actually is a big difference. And so we also need to do that for the row. We need to have our integer around here. So before we had 0.0 and 1.0 and 2.0, but we can't put that in here. So we can't put in 1.0 for a column. We actually need whole numbers of 1, 2, and of 0. So we need to convert this to an integer. So if we divide, we actually get a float or a decimal number, but we need it as an integer. So we've changed our practical row to be an integer and our practical column also to be an integer. So if we run it now, we see we get the empty field printed. So now everything works. So really the problem was that if we divide by a number, we get decimal numbers. So we had to use this integer conversion here to convert the results to an integer from a decimal number. So it's player 1's turn. Let's enter the row. Well, our row is going to be, let's put it in the top left corner. So we're going to have row 0, so row 1, row 2, and row 3. Let's use row 0. And let's also have columns 0, 1, 2. So to put it in the top left, we'll put in column 0. And so we see when we print our fields, we've now put in the X up here. And now it's player 2's turn. And let's have player 2 put it in the top right corner. So the row is going to be row 0, 1, 2. So we want to put it in the top right, which is row 0. And our column is going to be 0, 1, 2. So our column is going to be column 2. So we see player 2 put their move here in the top right corner. Now let's say player 1 puts theirs down here. So that would be row 0, 1, and that's going to be column 0. So player 1 puts their move down here. And now let's say player 2 puts their move in the middle, which is row 0, 1, and column 0, 1. And now it's player 1's turn, and player 1 is going to put their move down here. So enter row 0, 1, 2. So row 2, column 0. And so player 1 has kind of won the game. But our program isn't ending because we're not really checking for that. And so those are things that we could add later. So for example, another thing that we're not checking for right now is please enter the row. So we could technically overwrite this. We could overwrite, well, if we go row 0, 1, 2, and if we go into column 0, we've now changed our X to an O. So we've kind of overwritten the move that player 1 has made before. So these are some little kinks and bugs in our program that are still taking place. So we can stop the code. And we can fix those using simple if statements. So we could check, for example, first here. So how would we fix this? Well, we have to add if statements where we would check, is the value empty? If it is, then we make the move. Otherwise, the move is invalid and the player has to make another move, and we could do that down here. So how would we do that? How would we stop this overwriting? So we could make a simple if statement in here, and we check if, and then if the current field in our move column and our move row is empty. So if in our current field our move column and our move row is empty, is equal to a space, so that means it's empty, then we can do this. And now if it's not, well, we're not going to do anything. And well, what happens then is, since we're not entering this if statement, so we only enter this if statement if the current field that we want to move into is empty, then we can make our move, and then it's player 2's turn. But if it's not, we don't do any of this, and we go out of this if statement, and we also don't execute this because we were inside this if statement, and we just print player 1's turn again. And we just kind of continuously ask for player 1's input until it's valid. We can do the same thing for player 2, so we can check if in the current field, in our move column, so in the column that we make the move in, and in our move row, if this is empty, so our empty corresponds to a space value. So if this value is a space value or empty, then we do this. Otherwise, we just don't do anything, and that automatically makes it that the players that it's not a new player's turn and stuff, and that just kind of leaves it as it is. So let's run this once to see the changes that we've made for this kind of simple override bug fix. So now it's player 1's turn, and let's put our value in the top left corner again. So that's row 0, column 0, and let's enter let's as player 2 try to overwrite player 1's turn. So we'll also try to put it in the top left corner. So row 0 and column 0, but nothing has happened, and we see that it's player's 2 turns here. We try to put it in the top left. It's still player 2's turn. Let's be stubborn, and let's try to put it there again. So row 0, column 0, still player 2 turns. Nothing's changed in our field. We'll concede. We'll put it in row 1, column 1, so in the middle, row 1, column 1, and now we see it's player 1's turn again. So now we have this simple kind of bug fix that the players were able to kind of overwrite each other's moves. So that we were really nice and simply able to do by just checking if the current field's value is empty, then we can add a new value. But if the value is not empty, so if this value is an X or an O, then we don't. Then we don't overwrite it. So for example, that also prevents the player from losing their turn by putting their move in the same spot. So if player 1 now tries to put it where they put it before, so row 0, column 0, also nothing happens. It's still player 1's turn, so they also didn't lose their turn. So maybe they put it down here again, which would be row 0, 1 in column 0, and now it's player 2's turn again. So we fixed the simple bug fixes that players can't really overwrite the game board, just through this simple if statement. And now we can expand on this example by checking if someone has won, and so we'd need to create several if statements to check. So how do you win a game? Well, you get 3 in a row, either vertical or horizontal or diagonal, so that's how you win the game. So after each turn, you could make a lot of if statements to check if someone has won a game. We're not going to do that here, just because it's adding a bunch of if statements, but these are all things that you can kind of do to make this game even more complete. But what we've created here is a very simple Tik Tak Toe game where we print the fields. We ask the players to put in their rows and their columns where they want to put their values. And once they do that, we put their value in the corresponding spot. We start off with empty fields, and we put in the values that they entered. We don't allow the players to overwrite each other just by having this simple checking mechanism here. We also found a very smart way to draw the field, and we've also created this very simple mapping. So columns 0, 1, and 2, and rows 0, 1, and 2, we were able to kind of map that and use our draw field function that we created in the beginning. So we've created this draw field function, and we saved our values in a kind of list which contains lists that resemble or that displays our current field in a list format, and we drew these list formats in the form of this field using a lot of print statements and for loops. So, I mean, we've actually done something really cool. We were able to create a simple game. I mean, the game isn't complete, of course. We need to actually check when someone has won. But like I said before, this checking isn't too difficult. You just need to add if statements in the end. And you need to check, you know, are there 3 in a row vertically, are there 3 in a row horizontally or diagonally, like this. So those are the ways that players could win. But we were able to kind of print this tic-tac-toe field to the screen. We were able to ask the players to input their moves. We alternated between players 1 and 2. If someone puts in an invalid move here, we don't do anything. We just ask them, we just kind of prompt them to do it again. Yeah, so this is kind of our first example of creating something really cool and practical. And we've used a lot of very good skills or very kind of common skills, just asking for user input, using simple loops, printing to the field, using if statements or else statements to check if things are equal or not equal, using lists to store data. So we've used all of our knowledge and we've created something really kind of almost complex and complicated and very intricate, just by kind of using our imagination and expanding on the things that we know and using what we know to kind of push it to the boundaries and create this simple tic-tac-toe game.